So to have the maximum bending moment, we are going to solve the equation of the shear force is equal to 0. Okay, so we'll have to solve the equation of the shear force equal to 0. So shear force is equal to 0, imply that we'll have 10x squared, 10x squared divided by 8 minus 20 over 3, okay, is equal to 0, which is what? That 10x squared on 8 is equal to what? 20 on 3, okay. So we'll have x squared, which is equal to 20, right, times 8 divided by 10 times 3, okay. Making the calculation, we'll have 20 times 8, 160. So we'll have is equal to 160 on 30. So x will finally be equal to what? To 160 on 30 all over under the square root. So divided by 20, okay, square root. So we'll have our x is equal to 2.3. okay, so 2.3 is the point where we have the maximum bending moment. So to have the maximum bending moment, you come now with this point. Actually, let me write the value of by here. By is equal to 20 per kilonewton. Ay is equal to 140 over 3 kilonewton. So avoid missing value, so lost some value. Okay, so this point now enable you to know the maximum bending moment. You just have to take this point and substitute in the equation of the bending moment to have the maximum bending moment. Okay, so you have Bm max, which is from maximum bending moment, will be equal to what? You have negative 10. Okay, you have 2.3 cube. You substitute directly x by in the equation by its value over 24 plus 20 times 2.3, which is x, divided by 3. Okay, so you have the maximum bending moment. Making the numerical application, divided by 24. Okay, 5.0, 5.1. Okay. Sorry, 20 times 2.3 divided by 3, 15.3. So you have here 5.1. Okay, minus plus 15.33, okay, which is approximately equal to 10 Newton meter. This is the maximum bending moment, maximum value of the bending moment actually. So it's approximately equal to 10 kilonewton meter. Now we can draw the table to have the value that we'll be using to draw the shear force and the bending moment diagram. Okay. Okay, let's draw the table. So you have table here. point. The force is okay. Point A x equal to 0. Point C with x equal to 2.3. Okay, x is equal to 2.3, the point where the maximum bending moment is located. So we have now the last point B with x equal to 4. Okay, so now we have the force, we have the shear force SF equation. We will put the shear force equation here. This 10x squared minus 20 over 3 divided by 8. Okay, then we have the bending moment equation. We have negative 10x cubed over 24 plus 20 x over 3. Okay, now we already know the value of the bending moment at point C is equal to x equal to 2.3, which is almost 10 kilonewton. Okay, so 10 kilonewton meter because of the moment. Now we have to substitute the other for the shear force at point x is equal to 0. You have negative 20 divided by 3. Okay, so we have 20 divided by 3. It's equal to, it's gonna give us negative 6.67. Okay, this in kilonewton. At point C is equal to 2.3. 10 times 2.3 square divided by 8. Okay, is giving 0, almost 0. Okay, so we have 0 there. And now we have at point B, by substituting by 4, we have 4. Okay, 4 square divided by 8 20. Okay, we have 10 times 4 square divided by 8 is equal to 20. 20 minus 20 divided by 3 minus 20, 13. So it's giving us 13.33. Okay, 13.33 for this value. And now we have also 13.3. Now we'll substitute x here. We'll have at x is equal to 0, we have obviously 0. And since we don't even have to compute here, you can check it directly for a hinge support. You cannot have a hinge support and a roller support, like support of your simple supported beam, and you have moment at the edges, actually at the end of your support. It means something is wrong actually. So you can check the calculation. You see that here you can have 0 and here you have 0 or 0.000 something, like something that is actually really close to 0. So now we are going to draw our shear force and the bending moment diagram. So let's just sketch it like this. Okay, let's assume this to be our structure. Okay, now we'll have this. Okay, for the shear force now we are going to take it into 3. This equal to 3. Okay, this equal to another 3. So we are going to take 1 centimeter for 6. Okay, so we are going to consider this. Let's just put it somewhere here. Okay, so let's consider this. Okay, we have our 2.3 somewhere here. Okay, now we have our 0, this 6. I will consider it to be 13 at this end here. We know that at x equal to 0 we are negative 6.7. So we consider 1 centimeter to be our 6. So let's just say this our negative 6.675. So now this is the negative 6. Okay, since it's negative, no need, it's represented downwards, so no need to put the negative now. So at here we know that we have 0, and here we have, let's consider here to be 1 cm, here to be 2, here to be 2. So we are close to our 13 here. Okay, this is our 13. Okay, so let's just take it like this. Okay, don't actually it's not a straight line for the shear force diagram. Actually, the shear force diagram, okay, actually it's not a straight line, it's a curve, so it's a bit curved. It's just that with the scale that I choose for drawing, so it's a curve here and it's a curve here, and it's changing, and it's 0 at 2.3. okay, so now let's consider the bending moment. Okay, this is our 2.3 again. Okay, now at 0, at x equal to 0 we are at 0, at x equal to this thing, at x equal to 2.3 we are at 10. So let's consider here 1 centimeter is equal to 6. Okay, so let's just assume that this is our 10 here. Okay, our 10 is somewhere here. Okay, so let's just project it like this. This is our 10 here. So at x equal to 0 we are at 0 for the bending moment. At x equal, at point B, x equal to 4 we are still at 0. So we have a curve like this, a parabol. Okay, so that's the bending moment diagram. Consider 1 centimeter for 6 kilonewton, and 1 centimeter here is equal to 6 kilonewton meter. Okay, so this is our bending moment. This is the bending moment diagram, and this is the shear force. I remind you, here is not a straight line, it's a curve, it's a bit curved like this, and here is curve. Also here we have our parabol. This is the maximum bending moment at x equal to 2.3 as we have found. So thank you very much. That will be all for this video. I hope you like the video. If you have any question, leave it in the section comment. Don't forget to like the video and subscribe to the channel. Remember, we are going to talk about structural analysis for a while.